So we're going to be starting a brand new chapter. Chapter 6 is all about quadratics, and today we're going to be talking about quadratic expressions with rectangles and squares. So first off, what is a quadratic, and how can it be used in non-graphing situations? Make sure that you have the warm-up done as well before you turn this in. So quadratic, so it's a polynomial expression or an equation with a single variable, and the highest power is going to be a 2. So we'll separate into two different categories. Either we're going to have expression or an equation. An expression, as you know, does not include any of those symbols, those verbs that we talked about before. So an expression that is a quadratic you have to make sure you have a variable x that's the second power. Then you can add whatever else you want onto there. I'll put a 3 on there and then make it a plus 7, something like that. This would be a quadratic expression. If you want to make it into an equation, you could then say something like 5x squared minus, you can also have lower powers like 2x plus 10 equals 1. That would be a quadratic equation. And then we have something called standard form of a quadratic. So the standard form specifically is an equation, and it has to be of the form y equals ax squared plus bx plus c. You don't necessarily need the y equals part. You could just see the ax squared plus bx plus c, and then a, b, and c are just going to be numbers. So for example, even if we didn't have the y equals part, you could say this is like negative 4x squared minus 3x plus 9. So your a, b, and c in the order would be negative 4, negative 3, and then positive 9 is a, b, and c. Whenever you do standard form, the only thing you have to make sure is that when you write these out, that has to be in order from the highest exponent that you have to the lowest exponent. So your highest exponent is 2, and the next exponent is technically a 1 here when you don't see it. And then there is no exponent here, so there's no x at all. Technically x to the 0 power. So our first example, we're just going to simplify this a little bit, and then we'll rewrite it in standard form. So we have a negative sign outside of a parentheses, so we'll distribute that as a negative 1. So it'll be 3x minus 5, negative negative, positive 2x squared. And then we're just going to rewrite this in standard form. So we're going to put the 2x squared first, and then the 3x has to come next. It's positive, so put plus 3x minus 5. And so that is now in standard form. Example 2. The expression 5p squared minus 14p plus 90 is in standard form. What are the values of a, b, and c? Very simple. They're already in order. So since it's in standard form, we have a is 5, b is negative 14, and c is 90. That's all you have to do for that one. They're already in order, a, b, c. If they would have to be out of order, you have to change it in standard form first, and then identify a, b, and c. All right, example 3. Chris and Sam are remodeling their kitchen. They purchased a 6-foot by 2-foot pantry door and are looking at different widths of molding to trim the door frame. If the trim is W inches wide, write the total area of the door and the trim in standard form. So if you look at a picture of this door, the door itself, we know how long and how tall it is here. It is 24 inches by 72 inches. So we know it's 2 feet here going across. But what we don't know is that there's a trim amount going around the door, and we don't know how thick that's going to be. So we just call this thickness of W. So what we're going to do is we're going to try to find the area of the door plus the trim that goes around it. And if you know the area of the shape, the whole thing, with the door and the trim, it just makes a rectangle. So if you know the area of a rectangle, it's just simply saying length times width. So we're going to write an expression out like this, using this formula of what is the actual length times the width. So looking at this picture, The length and the width, well, let's start with the length of how tall it is. So we'll go from 72 inches, so that's the bottom of the floor here to the top of the door is 72 inches, but then we're also adding a thickness of W. So this whole thing would be 72 plus whatever the thickness is of the trim going around it, this extra amount, W. So our length is 72 plus W. And then we're going to multiply that by the width. Don't get these confused. This is the width of the door. This is W, the width of the molding or the trim. Maybe I should have done like a capital W here. Okay, then we're going to do the width. So going across this way, the molding goes on both ends of the door, not just one end like we had when we measured the top to bottom. So this whole distance here would be what? Well, the door is 24 inches, and then we have to add 2 pieces of the trim. So it'd be a total of 24 plus a W, which is a total of 2W. So we're going to multiply that together with 24 plus 2W. Now, whenever you have two expressions like this, you have to put parentheses around it, and we basically have to do something called distribution, but it's like a double distribution. So if you have something with a plus or minus sign between two terms like this, and you're trying to multiply them together, we have to distribute. So the way you distribute it is you take one term and you multiply it by each of the other terms in the second set of parentheses, and then you do it again with the W. So I just draw 2 arcs going above and then 2 arcs multiplying below. So we're going to do 72 times 24. So that'd be 1,728 plus 72 times 2. That would be 144W. Plus, I'm going this way now, W times 24 would be 24W. Plus W times W, or 2W, would be 2W squared. And that would represent the area. The last thing we have to do is simplify a little bit and write it in standard form. So if you look at this, we actually have 2 terms that have W on them. These are like terms. They can be combined. Nothing can be combined with a W squared because there's no other ones, and then this one doesn't have a W at all. So we're going to combine those and also put it in standard form at the same time. So if we combine 144 with 24, that'd be 168. And we'll keep that one in the middle. And then this one's going to go at the end, the plus 1728. And then this one will go up front. So 2W squared plus. And now that would be in standard form. And that would represent the total area of the door plus the whole entire trim around it. Okay. On the next one here, before we get to our next example, what we were doing here is we're actually creating something called a binomial. We have 2 binomials here. A binomial just means the word prefix bi just means there's 2, and basically the word binomial means there's 2 terms. So what we saw was an expression with 2 terms. Terms are usually separated by a plus or a minus. So for example, if you had like x squared minus 7, that's a binomial. Some other examples would be, you don't have to have x squared in them. They could just be, 5 minus 2x. But a lot of times they are something where you can't combine them. So you can't combine these because they're not like terms. But as long as you have 2 terms, they're considered binomial. We'll do one more. We'll do 6x squared minus 2x. Again, they're not like terms. You can't combine them. So those are binomials. Okay. Example 4. Write the area of the square with the side lengths x plus y in standard form. So this is a square because both of the edges are the same. So this is an x over here and a y. This side has an x and a y, which would mean the same thing would happen over here. Like this would be y, this would be x, And then same thing up here, we'd have y and x. So it is a square. All the side lengths are the same. So we're going to find the area of this whole thing. So one way to do that is we're going to take the entire distance here, which would be x plus the additional y, and we're going to multiply that by the entire distance here, which is also x plus y, and see what happens. Again, we have two binomials, x plus y times another x plus y. And we're going to multiply them together just like we did with the door problem. So we're going to do two arcs this way, so x times x, which is x squared, xy stays like that. And you multiply these two together, it's yx. And then y times y is y squared. And actually, believe it or not, we do have like terms here. xy and yx are the same thing. They are interchangeable because they're multiplication. So you could call this one xy and this one xy. It doesn't matter. And total, you would have basically 1 plus 1. You'd have two of them. And that's our answer. So we're going to denote that the x is the variable that we're saying is the variable in this case. So x squared would be first, then we're going down to a lower power of just x, and the last one has no x. I know this has y squared in it, but our standard form we're going to say is from the highest power of x, so x squared down to no x's. That'd be our standard form. And so this is actually kind of like a common thing that you might see where you see two things of the same being multiplied together, and you can kind of use this as a shortcut, which I'll show you how to use as a shortcut later. Some people don't like to do it as a shortcut, which is fine. So then you can just multiply them out like this. But I'll show you what I mean by a shortcut where you square one thing, you square the other, and then you multiply them together by times 2. So we already have one of our fill in the blanks down here. This is the same thing. If you see x plus y being squared, that is what we just did. This means the same thing as x plus y squared. Because there's two of them, so that means it's being squared. And so we just did this answer. The answer we got was x squared plus 2xy. Oh no. Plus y squared. And then we're also going to do one with, like, what if we put a minus sign between them? So we'll do this one the longhand. What if we have 2x minus y's? And we'll go through this one quickly. It's kind of the same answer, just you have to worry about the negative sign. So if you do x times x, x squared, x times negative y, negative xy. Same thing here. You have a negative sign this time, so minus xy, or you do yx, doesn't matter. Negative times a negative would be a positive y squared. So this time we're going to get x squared. These two can be combined again, two negative ones essentially. So minus 2xy plus y squared. And again, you can kind of use these as like a little bit of a shortcut to kind of help you do these kind of problems quickly. So we're going to do one kind of like this so you can see it. So it says expand the following 2r minus 5s squared. So because it kind of meets the same setup as this one, the second one, we can use the fact that like this position of x and this position of y, the answer comes from just squaring the first one, squaring the last term, and then multiplying those two numbers together times a negative 2. So I'll show you what I mean. You can also write out like I did just here, like you could do the same thing step by step and get this answer, but I'm going to show you a little bit of a faster way. So pretend like this is your x and this is your y. So this just says if you're going to solve a problem like this, instead of writing it out twice and multiplying it together, you could do 2r times itself. So you're going to square this whole thing. That becomes 4r squared. And then we'll leave a little bit of space and we'll do the next one. So all I did was I just squared this x value that was here. That's where this comes from. Then I'm going to square the right side, which is the y squared here. So we're going to square y, which is 5s. 5 times 5 is 25, and that would become s squared. And then this middle term comes from doing x and y together, which in this case is 2r and 5s, multiplying them together, and then you also multiply by negative 2. So we're going to multiply 2r, 5s together, times a negative 2. So it looks like this. 5s. Put a little plus on the end there. So that's an s. And you could probably do this in your head as well. You don't have to write this out. So our answer would actually be 4r squared. Multiply the 2's together, which is negative 4 times 5, which is negative 20. rs plus 25s squared. And that would be your answer. That's just a little bit of a faster way. And once you start using it and practicing it, it's actually a lot faster. Just to try to remember, I'm just going to square what we have here, square what we have here. You multiply them together and multiply by a negative 2. So the reason you do a negative 2 is because back here this was a minus 2x, or minus 2. And that comes from the fact that this was a minus sign between the two. If you do the one up here, you use a positive 2 instead of multiplying by a negative 2. So it takes some practice, and some people don't like it at first. So if you're stuck doing this, where you multiply it all out and add like terms, you can do it that way. This is just a little bit of a faster way of doing it. So if you try it and get used to it, you might like it more. Okay, last example, and then you guys can finish up the rest of 1, 2, and 3. Yep. Okay, last example. A group of students are working on a group project. They are given a 40-inch by 30-inch poster board. They are told to put a border on the poster board. Assuming that the border is x inches all the way around, write an equation for the area of the inside of the poster board, not including the borders, in standard form. So we're going to get a poster board. It's 40 by 30. So we'll pretend that this is 40 from here to here, and this is 30. So we're getting this poster board, and then what we're doing is we're putting a border on the poster board. So on here, we're going to draw maybe a border that goes around like this. And it could be some kind of design on it. I don't know. I just kind of made a shape here. And the thickness of this border all the way around is x. Whether you're looking at this way, down here, over here, it doesn't matter. We're going to try to find the area of the inside of the poster board, not including the border. So we're trying to find the area of just this piece here, how much space this is. This is going to be a little bit different. When we find the area of this, it's obviously going to be a rectangle again. But this time, when we do length times width, we're not including the border. We're actually taking it out. So if we're going to do the length of this would be 40 inches. But then instead of adding this extra thickness here of x on top and bottom, we're subtracting it. So we're taking 2 of these x's away. So minus 2x. Then going across the top, it'd be the same thing. This whole thing is 30. So start with 30. And we're going to subtract 2x again because there's 2 borders here. There's one here and one over here. So this distance inside of here is 30 minus the 2x's. And then we're going to multiply them together like we did before with the door problem. You multiply this, this, and this, and this. You just try that yourself and see if you get the same answer. And then we'll also have to remember to convert it to standard form. So if you multiply 40 and 30, you get 1200 plus multiply 40 times negative 2 will actually give us a negative 80 x. Negative 2 and 30 is minus 60 x. And negative 2 would be a positive 4x squared. And all we have to do is combine like terms and put it in standard form. So we combine those two and make it a double negative. So it's negative 140x. This will come out front, 4x squared. And at the end, we'll have 1200. And that would be our area in standard form. 4x squared minus 140x plus 1200. And by the way, if you didn't know the thickness of the border around it, you could plug any number in for x. Like if you wanted to make it 1 inch or 3 inches, you could just plug that into the spots where x is in this equation. You could find the area inside of it. If you ever wanted to change how thick the border was, you could figure out how much area that was inside here. So that is all for this lesson. for 6.1. So you can finish up the huddle, which is 1, 2, and 3. Try those ones out. And then also don't forget to do the warm-up all the way at the beginning. Once you're done with that, you can turn it in.